Our next topic is conversion of galvanometer into ammeter. Ammeter is an instrument used to measure current flowing in the electrical circuit. An ammeter must offer low resistance. So, galvanometer is connected into an ammeter by connecting a low resistance in parallel with a galvanometer. This low resistance is called shunt resistance. Let I be the current passing through the circuit, and this I reaches at the point A. It divides into two components. Let Ig be the current passing through the galvanometer resistance Rg through the path AGE, and remaining current I minus Ig passing along the path ACDE through shunt resistance S. Therefore, the potential difference across through the galvanometer is same as the potential difference across shunt resistance. Therefore, V galvanometer equal to V shunt. Therefore, V galvanometer is nothing but it is known as IGRG, which is equal to I minus Ig into S. So, we can calculate S is equal to IGRG divided by I minus or Ig, or Ig equal to S by S plus Rg into I, which is equal to Ig is directly proportional to I. So this Ig is a deflection in the galvanometer is directly proportional to the current passing through it. Therefore, the deflection in galvanometer measures current I passing through the circuit. Therefore, theta equal to 1 by G into Ig, which is equal to theta is directly proportional to Ig. Therefore, theta is directly proportional to I. And next, the shunt resistance is connected to the parallel in the galvanometer. Therefore, the resistance of ammeter can be determined by computing the effective resistance. Therefore, the 1 by R effective is equal to 1 by Rg plus 1 by S. Therefore, R effective is equal to Rgs divided by Rg plus S, which is equal to Ra. Since the shunt resistance is very small, that is low resistance, and the ratio 1 by Rg is also small, this means Rg is also small. Therefore, the resistance offered by the ammeter is small. Suppose if connect the ammeter in series, the ammeter will not change the resistance. For an ideal ammeter, the resistance must be equal to 0. Let I ideal current measured from ideal ammeter and I actual current be measured in circuit. So the percentage error in measuring current through the ammeter is del I by I into 100 percentage. Therefore, I ideal minus I actual divided by I actual into 100 percentage. And next some few key points. One is an ammeter is a low resistance instrument and it is always connected in series to the circuit. Second one, an ideal ammeter has zero resistance. Third one, in order to increase the range of an ammeter n times, the value of shunt resistance to be connected in parallel is S equal to G divided by n minus 1. Next topic is conversion of galvanometer into voltmeter. A voltmeter is an instrument used to measure potential difference across any 2 points in the electrical circuit. A galvanometer is converted into voltmeter by connecting the high resistance RH in series. The scale is now calibrated in volt. The range of voltmeter depends on the values of the resistance connected in series. From this diagram, Rg is nothing but it is known as the resistance through the galvanometer, and Ig is known as the current through the galvanometer. Therefore, I is equal to Ig. Therefore, which is equal to potential difference by total resistance. Since the high resistance connected in series, therefore the voltmeter resistance Rv equal to Rg plus Rh. Therefore, Ig is equal to V by Rg plus Rh. Therefore, RH is equal to V by Ig minus Rg. Therefore, Ig is directly proportional to V, that is potential difference. Deflection in galvanometer is directly proportional to Ig, but Ig is directly proportional to potential difference. Therefore, the deflection in galvanometer is also directly proportional to the potential difference. Therefore, the resistance of voltmeter is large. Next, some key points under the topic of galvanometer into voltmeter. First point is voltmeter is a high resistance instrument and it is always connected in parallel with the circuit element across which the potential difference is to be calculated. And second point, an ideal voltmeter has infinite resistance. And third one is, in order to increase the range of voltmeter, n times the value of resistance to be connected in series with the galvanometer is or equal to n minus 1 into G. Up to this, your third lesson is over. Thank you, children.